All right, hi folks, this is Larry Mussolino. I'm recording a video here for STAT412, and I wanted to go over a few of the examples from the Module 2 homework assignment in my lab. So let me get started here with the first one. So it's giving us a probability density function. And by the way, we call this a discrete distribution here because X is only taking on these particular values of 0, 1, 2, 3, 4. So this is a discrete distribution. And what they're asking us here is find the average number of imperfections. Okay. Well, if we want to find the average, another way to say that is the mean. And the formula for finding the mean of a discrete distribution, this is in section 4.1 of the text. So this is section 4.1. You'll see it says the mean is, and by the way, we write the symbol mu here for mean. It's the sum of x times its f of x value. Well, in this case, we're going to take the sum from 0 to 4. So this is going to be kind of a simple calculation. I'm going to take each x value and multiply it times its corresponding f of x value, and then just add up the results. So I'm going to start out with x equals 0. Start here with x equals 0, multiply it by its function value, which is 0.43. Now I'm going to go x equals 1. I'm going to take that x value of 1 multiplied by its function value, 0.39. Keep going in the same way. Now x is 2, its function value is 0.12, and so on. 3 gets multiplied by its function value, 0.05, and finally 4 multiplies 0.0. And then all I have to do is work this out on my calculator, and this works out to be 0.8. So this is the mean for this example. All right. Let me go to another example. Let's go to number 2. All right, number 2 is the same idea because, again, they're giving me a discrete random variable x. I know that because I can see x is only taking on 0, 1, 2, 3, and 4 in this model. It's not like x can be, 1.793. No, it's not allowed. X can only be 0, 1, 2, or 3. That makes this a discrete distribution. So they want the mean. Again, that's the same as the average. And the formula is the sum of x times its function value. Now here, the function value, f of x is not given to me. I've got to calculate it. And it's a little messy, but here's the definition of f of x. So let's let x equal 0. Well, if x is 0, it's going to be the x value of 0 times. Now, what I'm going to do is take this function value, and anywhere I see an x, I'm going to replace it with 0. So this is going to be 3 0 combinations, 3 over 8 to the 0, 5 over 8 to the 3 minus 0. Of course, I'm not going to work any of this out because 0 is going to multiply this, so this is just going to be a 0. But let me go. So this is the case where x equals 1. Where x equals 0. So let's come over here to the case where x equals 1. Well, for that, I'm going to take the x value of 1 and multiply it by its function value. All right, so now I got to go to this f of x definition and replace x with 1. So this is combination 3, 1, 3 to the 3 over 8 to the exponent 1, and 5 over 8 to the exponent 3 minus 1. By the way, when you see this 3, 1 combination, remember this really means 3C1. And then, of course, you're going to do the same thing when x is 2, and then the same thing when x is 3. All right, this will be a little messy, but you can work this out on a calculator. And in my example, you could see this works out to be 1.12. All right, let's go to a different one. Let's go to number 3. All right, number 3 is telling us that 2 tire quality experts examine stacks of tires and assign a quality rating to each tire on a 3-point scale. X is the rating given by expert A, Y is the rating given by expert B. So these ratings might be the same, or they could be slightly different, right? Expert A and expert B might judge the same tire slightly different. So here is the joint distribution in this table. So let me click on this table so we have it. All right, so here's the joint distribution. And what they're going to ask us to do is find the mean for X and the mean for Y. All right, let's start out finding the mean for X. So let's do the mean for X. Well, the formula here is to take the sum for the X values times what's called the marginal distribution for X. So this G of X is going to be the marginal distribution for X. So what I have to do is, here are the X values, and here are the probabilities for the different X values. What I'm going to do here is add up the rows. So this G of X is really going to end up being the row total. So let me add up these rows. I think this is 0.19 for that row. I'm going to add up the second row. The second row is 0.51. And the third row, let me just double check this on my calculator because I don't want to mess up. The third row is 0.3. Yep, 0.3. All right, so now I'm going to go ahead and work out the summation. So X is 1. Its marginal distribution is value is 0.19. Now I'm going to let X be 2. The G of X function for that is 0.51. You can see these are the row totals, plus 3 times 0.3. And if you work this out on your calculator, this is 2.1. All right, let's do this. The other part. What about the marginal, the mean for Y? Well, for that, we have to take the sum of Y times its marginal distribution. Well, this marginal distribution is going to be adding up the columns. So I'm going to go ahead and do a column total here. So these values, let me do this in a different color just to make it stand out. So these column totals are going to be the H of Y values. Because you can see these columns are representing the different Ys. So let's see, I think this one's going to be 0.18 for this Y value. I think this is going to be 0.51 again, is that right? And this one here is 0.31. All right, so now Y is 1. So I'm going to take this Y value of 1 times its column total of 0.18. And I'm coming here to the Y value of 2. Its column total is 0.51. And finally, Y is 3. Its column total is 0.31. And if I work this out on my calculator, I get 2.13. So that is this mean for Y. Okay, so in this joint distribution table they gave me, I had to calculate the row totals, and I also had to calculate the column totals. All right, so that's that example. Let me go to another example. All right, let me take a look at this example. This is number 4, homework 4. And again, this is giving me a discrete distribution. I can see X is taking on these values going from 2 to 6. All right, and it's asking us to find the variance. Well, if they're asking us to find the variance, the symbol is sigma squared. The formula, this is in section 4.2, by the way. The formula for the variance of a discrete distribution like this is you have to take the expected value of X squared minus the mean squared. All right, let's do the mean because that's going to be the easiest part. If you remember, we just did an example like this. The mean is the sum of x times its f of x value. So let's just work it out. The x value is 2 times its f of x value, 0.3, then 3 times 0.04. I'm just taking each x value times its corresponding f of x value from the table, and then 5 times 0.01 plus 6 times 0.4. So this is the mean. I'm going to work this out quickly on my calculator. And if I do that, I'm getting the mean is 4.17. All right. So now let's figure out the expected value of x squared. Well, for that, I'm going to take the sum of the x squared value times f of x. So let's work that out. We have 2 squared times 0.3 plus 3 squared times 0.04 plus 4 squared times 0.25 plus 5 squared times 0.01 plus 6 squared times 0. All right, I'm going to work this out on my calculator quickly. And if I did that right, let me double check that one more time here on my calculator. And I think I'm coming up here for this result of 20.21. All right, I'm ready to plug in now to find the variance. So it says for the variance, I want the expected value of x squared. We just figured that out as 20.21. And subtract the mean squared. Well, we figured out the mean is 4.17 squared. And if I work this out on my calculator, I get 2.82 when I round to 2 decimal places. Okay, so this is finding the variance of a discrete random variable. All right, folks, let me come here to question 5. Now, this is an example from chapter 5. This is actually from section 5.2. And this is an example of what's called a binomial distribution. So let's read this over and try to see why is this a binomial distribution. It says in a certain city district, the need for money to buy drugs is stated as the reason 49% of all thefts. Find the probability that in the next 5 thefts, exactly 2 resulted from this need to buy money, the need for money to buy drugs. So a binomial distribution is when you repeat an experiment over and over. We're going to say n times, and sometimes say n trials. For each trial, there's only 2 outcomes. That's why it's called binomial. You know, you could think of this as like true, false, or success, failure, heads or tails, any way you want to think of it. Okay. In our example, the binomial nature is the theft was the need to buy drugs or it was not. And we want to know the probability. We want the probability for a certain number of successes. All right, so when you work with a binomial distribution, you really need 3 quantities or 3 parameters. We call it n, the number of trials. For our example, it's going to be 5, right? Because we're analyzing 5 theft cases. You need to know the probability of success. In our case, it's 0.49, because we were told that 49% of all thefts are due to needing money to buy drugs. Not that that's a success, but we're just terming it. We're just labeling that as a success. And then X is the number of thefts due to needing the money to buy drugs for the problem. So for us, X is 2. We're doing part A of the problem right now. All right, so we know these 3 quantities, N, P, and X. And again, the reason I know this is binomial is it's 2 outcomes. I'm repeating an experiment over and over where there's 2 outcomes, and this probability of 49% stays at a constant. All right, well, there's a messy formula in the textbook, but usually we don't use a formula for this kind of analysis. We use technology of some kind. And Excel does this very nicely. So let me show you how to do this in Excel. So in Excel, there's a formula. And what I'm going to do is the formula is called binom.dist. But it's a little messy to use this formula. So I'm going to provide you with a calculator to do this for you automatically. So let me show you what this calculator looks like. I'm going to post this in course announcements so you have it. Let me share my screen for this calculator. Let me do it here. Bear with me one second. Let me move this over like this. And here's the Excel calculator that I'm going to share with you. By the way, I have a little calculator here. When you want to find the mean of a discrete distribution, if you enter the X values in this yellow column and enter the probabilities in this column, this will automatically calculate the mean for you. This is just using that formula, the sum of X times F of X. If you want to use that as a little bit of a shortcut, you can use that also. But I want to come over here. It says to find binomial probabilities. This is the formula to use. But to make it a little easier, I've created a little bit of a template here. So I'm going to come over to these yellow boxes right here. All right, so notice it says here is a value for N, P, and X. And once you enter values into these yellow boxes, behind the scenes, Excel is going to use this binom.dist function to come up with the probability of exactly X successes, probability of fewer. This is like a less than symbol here. So this is the probability of X less than a certain number. Here's X or fewer. So this is like X less than or equal to. Probability of greater or greater than or equal to. So depending on the wording of the questions, you can get your answer from one of these 3 boxes. So let's do part A of our example. Part A for us, N was 5, right? Because there's 5 theft cases that we're analyzing. P was given to us as 0.49. And for part A, we want them to know the probability of X equals 2. So X is exactly 2. All right, instead of using the messy formula, I'm just going to let Excel do the work for us. So let me go to Excel. And let me come over here to this first yellow box. Our N is 5. Going to the second yellow box, P is 0.49. And for the third box, X is 2. And I want to go and get this first answer here for the probability of exactly X successes. So our answer here is 0.318. All right, so that got us the answer for part 1 of the question. Okay. And so let's go to part B. Part B says, what's the probability of X less than or equal to 3? Well, again, I'm going to let Excel do the work for me. N is still 5. P is still 0.49. And now X is 3, but we want to know the probability X less than or equal to 3. Well, less than or equal to is going to be X or fewer. So I'm going to be using this green box for my answer. But I've got to change the X box to be a 3. So let me change this X box here to be a 3. There it is. And I'm going to go to this green box right here. And so our answer is going to be 0.825. Okay, so this binomial calculator is going to make these binomial kinds of questions easier. Please feel free to use this binomial calculator for the homeworks, for the quizzes, and I hope this is helpful. So again, I'll post this calculator in course announcements so you have it available. All right, hope this is helpful to get you started on the Module 2 homework. Please let me know if there's any questions.